Yeah, perfect. So maybe a quick introduction about myself, and then quickly about Adaptive6, and then we could dive into the main topic, of today's webinar, which is shadow waste. So pleasure to meet you all. I'm so very, very excited to be in this panel. I'm Aviv Revach. I'm the CEO of Adaptive6. I also recently joined as a governing board member to the FinOps Foundation. And originally I come from a cybersecurity background, and actually our entire leadership in the company, we all come from cybersecurity background, and we actually see a lot of resemblance between the space of cybersecurity and the space of FinOps, where in cybersecurity you sort of have the CISO trying to get everybody to think about security and so on. And in FinOps, you've got the FinOps folks or the cloud ops folks trying to basically get everybody to think about cost. Now, in cybersecurity, it's pretty mature today, right? So it's been there for a while. So there are a lot of very advanced tools, a lot of very advanced methodologies, and in cloud cost, it's just getting started. So this is where we actually see a lot of potential to bring a lot of the methodologies from the world of cybersecurity into the world of cloud cost. And when talking about shadow waste, I think it really resembles a lot of the research work that is being done in cybersecurity and so in other fields and so on. Great. So that's a little bit about me. By the way, some people call me the tallest guy in FinOps. I don't know if it's true, but that's my one-liner. So maybe a short introduction, just like 2 minutes, about 1 or 2 minutes about Adaptive6, and then we could dive into the topic itself. And feel free to ask any questions, during the session or afterwards during the Q&A. So very quickly, at Adaptive6, we're in the space of cloud cost governance. We primarily serve Fortune 500, Fortune 2000 companies. These are big enterprises. They have very small FinOps team or cloud teams, and they have lots and lots of engineers, and things get out of control. And this is exactly where you really need governance. Our motto typically is, as you might see here in the battle, is don't observe, govern, because I think there are a lot of observability tools out there that help you with financial aspects. But it's really, I think the next generation of FinOps is all around governance, both of your multi-cloud environment as well as your infrastructure as code. So very briefly, what we do in the company, 4 main things. Number one, we govern the entire infrastructure, multi-cloud and platform as a service like Databricks, BigQuery, Snowflake, and others. And then we detect more than 100 different types of waste and shadow waste. And when I say shadow waste, this is going to be the topic of today's talk, obviously, and so on. And this is a very comprehensive, list of detections. We're now going into more than 500 and so on, and that's really the goal. Number two, other than finding the issues, we actually help organizations remediate at scale. So it's not just about finding the issues, but exactly connecting to Eric's point, how do we communicate this back to engineers? So we actually close that loop by automatically finding the owner of each one of these issues based on our proprietary technology. It's called Cloud to Code, or based on the tags. And then we automatically communicate issues to engineers through Jira tickets, Slack, Teams, ServiceNow, and so on, giving them all of the context they need, while we also handle exceptions, follow-ups, escalations, and so on. The third aspect of our platform is essentially fixes with AI. So we are the only platform out there that really leverages AI to this extent of actually fixing infrastructure as code and basically providing and empowering engineers with the right, not just the right context, but with the right code fixes. And then with one click, they could basically push this back to their Git as part of their standard development process. And the fourth and last piece of what we do is that we don't just focus on the waste and shadow waste you have in the cloud and how to remediate that, but actually how do you shift left and prevent it from the get-go. So we actually embed cost efficiency into the pipeline. So you could basically say from now on, for instance, no more GP2, right? And you could enforce those kind of policies. So that's very, very briefly about Adaptive6. Moving on. So moving on to today's topic, what my personal goal for today's discussion, it's all about shadow waste. I think that for a long time, the FinOps community, myself included, we all talked about, waste, right, which is a big thing in the industry and so on. And I think I see more and more organizations now asking, okay, what's next, right? What's next beyond the, the standard things that we typically see with the cloud service providers, with tools like Azure Advisor or AWS Trusted Advisor, or with some of the observability tools of the world and so on. And this is where shadow waste kicks in. But right before we discuss shadow waste, maybe we should start by, defining what waste is, right? So this is the official, definition by the FinOps Foundation talking about waste, which is any usage or cost of resources which provide no value to an organization, right? And you guys know the stats the same as I do. And common types of waste that you guys are very familiar with, I will be certain, are, unused resources, over provisioned VMs that require right sizing, storage buckets that don't have proper archiving or intelligent tiering, and these kind of things and so on. This is the standard waste that we basically, as a community, we all talk a lot about these days and so on. What I want to present next is the definition of shadow waste, and then we're going to dive into very concrete examples. My personal goal today is basically for you to basically have the ability to take these home, very actionable insights, and back to the office and basically check these type of things in your organization to make it worthwhile for you. So when we talk about shadow waste, and this is just the definition that we have for it in the company, it's basically the following. Shadow waste refers to hidden or overlooked inefficiencies that basically evade the standard cost management practices, just like I mentioned, typically due to the fact that you have some complexity in the infrastructure or lack of visibility and so on. But I think other than the definition, I think the best way to describe it or to think about it is through examples. So I try to list here a few examples of different types of shadow waste that basically fall under that definition. So one is complex service configurations. You have a lot of services across the multi-cloud environment. In some cases, it's easy to configure the service. In other cases, it's very complex. We're going to see some examples to that later on with DynamoDB and others, where it gets very, very tricky for a FinOps person to basically look at it and decide what to do and so on, and we're going to see that. Another type is service configurations that are advanced. In some cases, people are well aware of the typical things you can do in terms of configuration, but there are some hidden or advanced capabilities that people don't typically think about. So we're going to touch on that. Another type of shadow waste is architectural inefficiencies. So these are not just, things that you basically fix with a standard configuration. This might require a little bit more effort on the engineering side, but the gains could be very, very significant, right? So that's another category. The fourth one is applicative setup and configuration. So when we think as a community about shadow waste and about waste in general, we typically stay in the scope of the infrastructure itself. When I'm talking right here about applicative waste or applicative setup and configuration, this is actually within the workload itself. So these are not the typical things when people think about waste that people typically think about. This goes a further step. Other examples, and I will just run over these quickly so we could get into the actual examples. Niche services that people are using within the different clouds. In some cases, different types of platform as a service, like Databricks, that a lot of folks use and don't have a good way to basically find shadow waste over there. Many times you have production and dev environments that look pretty much the same, and that basically creates a lot of shadow waste, and we're going to talk about that. And you can see some of the other examples and so on. Let's dive into concrete examples. Essentially, I've got 6 examples to share with you today, and then we do like a quick recap afterwards, and then some time for questions. So, number one, this basically talks about the nature of some of the service configurations being very complex, right? So in this case, let's talk about AWS, but we're going to have examples for all clouds and so on. So in AWS, obviously you've got DynamoDB database. DynamoDB has basically 2 modes, 2 throughput capacity modes: on demand and provision. This is one of the areas where it gets very, very tricky, and we've basically seen a lot of customers basically get these confused and so on, where the way that AWS charges really depends on the mode that you choose, and choosing the right mode could also get very, very tricky. So when you look at on-demand capacity, if you choose that option to basically just pay on demand for DynamoDB, you could see right here the way it's charged, around 12.5 cents per 1 million read request units. This means request to the DynamoDB for read. And this is just example for read. You could do the math for write as well. When you do provisioned capacity, however, it's built in an entirely different way, and you could see how much it's cost per hour, and this is per what they call provisioned read capacity, right? So this means read request unit per second, just one of them, and then it gets built over an hour. As you can see, this could get very, very complicated in terms of understanding what exactly does each and every one of your DynamoDBs require. So if we take a quick example, if you have 100,000 read requests per second to your DynamoDB table, basically if we look at the different numbers right here, on-demand capacity will bill you at $45 an hour. Provisioned capacity you would basically get billed at $13 an hour, right? So in this case, you should probably be going for the provisioned capacity. The difference is quite massive, as you can see. It could save you a lot of money. There are other cases where it actually makes more sense to do on demand and the other way around, especially let's say if you have a workload where it's only open, a DynamoDB that basically only gets 30 minutes a day of read request, and that's it, right? And the entire day is basically idle. Then you might want to actually use on demand. So these things could get tricky, and this is exactly where you have a lot of hidden shadow ways that people don't typically think about because it's rather complicated to do some of this math and so on. Some word of some note I want to mention. It's really important when you do this exercise to continuously do it over time. It's not like a one-time thing. This could have high gains, but it would require some time and effort from your end. And also, if you do choose provision mode, just bear in mind that basically leave some buffers, right? When you do it, don't just do the exact minimum and so on, because after you basically pass the limits that you place on provision mode, you could actually get in trouble with throttling and so on. So these buffers are really important. And if you have any questions about that, feel free to send me an email after the session. I would share my email afterwards and so on. So this is my first example, and I hope it clarifies this type of waste, which is around complex service configurations. Moving on to the second one. So essentially, this basically talks about applicative waste, right? Applicative setup and configuration. When people typically think about cloud costs, they don't typically think about the workload, about the application. Now, this really amazes me because at the end of the day, if you look, for instance, at Python versions of workloads before version 3.13 could actually be up to 20% less efficient and more costly compared to this version of Python. Now, important to stress, this is not because of end of life. Like some folks, they're thinking, let's upgrade to the latest version because of end of life. This is not the case. This here is because they made a remarkable change, both in Python 3.12 and 3.13, that actually introduced a lot of new capabilities and optimizations to it that made it far more efficient. And most folks, and also many engineers, basically are unaware of that, and this could be a very, rather quick win if you have a lot of Python workloads and so on. And if you want to, and actually it could actually become even easier if you're using serverless functions like Lambdas, Azure functions, Cloud Run functions on GCP, then basically if you look at the metrics, you wouldn't see any problem. But if you look at the configuration, you could actually change that configuration. And obviously, you need to test this with your workload and making sure it works properly. But at the same time, the potential gains could be remarkable. Now, this doesn't just exist for Python. This is also for Java and Spark and various other types of applications and so on. This is just one example, the tip of the iceberg, just to get everybody to start thinking about these things that are costing a lot of money. And I think this is our journey as a FinOps community is going to this type of shadow waste. My third example is around production and dev, right? So essentially, you basically have production. Typically, you mirror to the same environment, in dev and so on. You pretty much keep it, very similar. in some cases, some folks, they are doing right sizing in dev that is different from the right sizing they do in production, which is very, very good because they think they understand that they don't have to be completely identical unless you're running some load testing tests and so on. But they don't necessarily think about the fact that you could have not just smaller VMs, but actually different configurations, right? And in this case, this is what we see out there in the wild with a lot of our customers, where basically you see a lot of unnecessary high cost without justification. And this is just a partial list. So in this case, you see in non-production, you see folks having databases with multi-AZ, right? Doesn't make sense, or high availability mode and so on in the other clouds. DynamoDB, global tables, right? Basically giving you, basically more regions that you serve from and so on. DynamoDB Accelerator, that's another example. This would give you additional performance. It's worthwhile when you are in production. Maybe you don't need it when you're in a dev environment, right? And then you have a couple of more examples right here, basically just stressing the point that production and dev don't need to necessarily be identical. There is a lot of waste that exists, shadow waste that exists within dev environments, and you just have to start looking for it and so on. And these are just a couple of examples. Moving on to the next example, I believe. So right here we're talking about a different type of shadow waste. In this case, this is architectural inefficiency, right? So it's not just a configuration aspect, and it's not in the application as we saw. This is within the service, right? Within the service, the service architecture that you basically have. So in many cases, what you typically see is the diagram down below. You basically see that folks are using NAT gateways in order to allow EC2s to that basically are placed in private subnets to access S3. What really happens behind the scenes is that when you have this setup, the EC2 would basically go all the way to the web, to the internet, and basically all the way to the S3 bucket and so on. This is very wasteful, and there are basically better ways to do it, right? And this is one of these areas of shadow waste that when you set up when engineers set up the system at the very beginning, this might really make sense. But over time, you actually have a lot to gain by actually changing the architecture to move to VPC endpoints, right? VPC endpoints basically is a capability, in this case by AWS, that basically helps you to dramatically reduce the cost, because then the access from the EC2 to the S3 doesn't go throughout the internet, right? So this saves a lot of cost and so on. So this is a good example how somewhat a small change into the architecture would basically save a lot of money. Of course, it requires a conversation with the relevant engineers and so on, but it really is a low-hanging fruit in that regards. Then I think I have two more examples for this session, and then we'll basically do a recap, and then we can discuss how do you actually identify more of these and so on, not just the examples that I gave here. So this is really, I think this is the fifth example. So this talks about, you've got services. We all know, pretty much the standard way of configuring them, but then you have advanced configurations that people don't necessarily think about on a day-to-day basis. One of those, in this example, an Azure example, is ephemeral OS disks. So what happens is that if you have workloads that are stateless, and by stateless, I mean they don't necessarily need to basically have their state kept on an ongoing basis. For instance, most of the web servers, you could actually switch from a standard, in an Azure VM, from a standard storage into ephemeral OS disks. What this does is that instead of using the standard, storage that Azure provides, this would actually use the VM's local disk, and basically would save you cost, because using the local disk would not incur any cost, right? This is just free of charge and so on, included with the price of the VM. This is a really good saving opportunity, right? For shadow waste and so on. You do have to bear in mind, this is just for stateless workloads, right? So when you have these conversations with the engineers that you work with, make sure to understand whether it's a stateless workload. Typically, web servers are a good candidate for that, and you might be able to switch to ephemeral, and you could save a lot of money by doing that. I think this is my last example. So right here, I'm talking about a different type, which is niche services, right? So we talked about configuration of existing services, some advanced configurations. What about some services that are not the common ones we all talk about? We all talk about the EC2s and the VMs in Azure and other clouds and so on. We all talk about databases. What about the other ones? Whether it's within the multi-cloud or whether it's within platform as a service, right? So for instance, if we take Databricks as an example, you don't typically have a lot of ways to see, the waste and what's going on within Databricks. So this is just, a very low-hanging fruit example. And Eric mentioned, shutting off servers. So this connects. Basically, when you look at Databricks, you have a way, basically, when you use interactive clusters in Databricks, you have a configuration for auto-termination for these clusters. So essentially, all you need to do is just activate this configuration, and this is it. Otherwise, these interactive clusters will just stay live for a long period of time, and this could be extremely costly. And most folks, they are just not necessarily aware, and it's really, really hard also to keep track, right? And I know of every single service that the cloud providers offer, every single service and configuration that that you have for Databricks and these kind of services and so on. So this is a good example. There are more. Be on the lookout and look for them and so on. So a quick recap of all of these examples, and then I'll dive into the last slide, which is going to talk about how do you find more of these, right? So what have we seen, right? So we're talking about what shadow waste is, and then I covered a few examples. Number one, complex service configurations, right? So you have, in this example, DynamoDB, throughput capacity. How do you choose? Very complicated to do this configuration, a lot of potential gain. Another example of shadow waste, applicative setup. You go inside the application, inside the workload. You don't just stay in the infrastructure. This is the next frontier for us as FinOps folks within the community. The third example is production and dev mirroring, not just keeping the exact same unless you really have to, right? If you need to do it for performance, do that. But in many environments, you don't need to keep the same level of performance. Look for these things, whether it's multi-AZ, whether it's DynamoDB accelerator, whether it's other types of what I showed before in the previous slides. The fourth example is architecture inefficiency, where you could make some changes, sometimes small, sometimes slightly bigger. In this case, not a big one. Switching from between NAT gateways and VPC endpoints. The next one is service configurations that are rather advanced that people don't typically think about, like Azure Ephemeral OS this. And the last one is niche services, whether it's within the cloud, people are using SageMaker and so on, and don't really get to think about what are the possible ways to optimize it, or whether it's within the platform as a service like Databricks, Snowflake, BigQuery, and others. We also talked about some other types of shadow waste. I don't have time today to cover them, maybe in a follow-up discussion, but I hope that this gives everybody sort of an understanding of what shadow waste is, concrete examples that you could basically start looking for inside your infrastructure. Many folks basically that I talk to, they say, okay, we already got the obvious things covered. What's next? So this is it, right? And then my last slide right here is how do you actually find shadow waste, right? Like other than these examples. So I think first of all, and this is how to do, you need to get a little bit more into the technical aspects of each cloud and each service. It could be very hard. I would advise you to look at your top 10 resources, not just the top 5, and start, basically starting to read about these things more specifically. Number 2 is to start and look for the best practices and the pitfalls and so on. I think that the FinOps Foundation is doing a great job at accumulating a lot of this information. There is a lot of information out there. And then I think another thing that I think we all as FinOps folks really need to adopt more and more, and the community is talking about it, is AI. I think that AI is your best friend when you're talking about shadow waste, because I saw the questions that you guys raised to Eric about not necessarily knowing all of the bits and bytes for the engineers, but I think at the same time, with AI, if you provide to an AI, to an LLM, basically the list of your top 10 highest spending resources and so on, and ask for best practice recommendations, you could gain a lot, right? Just by doing that. If you could add more context to it, like telling him about your specific workloads, even better, right? Always bear in mind that you need to check the official documentation. That goes without saying, because we know about hallucinations of LLMs. but at the same time, this is a great source of information. I truly advise you, to be doing that. And of course, there are other, places like these type of webinars where you could have access to this type of information. The third point here is basically trying to look for, resources that don't conform, that basically are not aligned with these best practices after you found these best practices. And the fourth point, as you could see, is essentially asking yourself these 4 questions. Why is it configured this way? Maybe there is a good reason, right? Is there an alternative cloud service that is better to do what I'm trying to do? Maybe there is a chance that this was configured a long time ago. This happens a lot out there in the wild from what we get to see. A lot of folks made a decision to do something a long time ago, maybe a year or 2 ago, and then 2 years later, the situation has completely shifted. And then am I paying, for some aspects I don't really need, because some of these configurations, they might not lead to high expenses and others are. So I know this is sort of a methodology that we are basically using, and I advise you guys to use also as basically looking into shadow waste and so on. So this is it. We're going to have a Q&A shortly, but I do want to share, this is a QR code, and basically you could see my email right here. If you have any questions, anything you would like to ask or just consult, really feel free to hit me up, and I would love to, to find some time and chat with you.
I think it was a wonderful presentation, Aviv. It was super, super interesting and full of value. So everyone is asking about the slides, so we will be able to provide those after the call. So we will send it on the follow-up email of this webinar to all the registrants. We will be able to share with you all the content